Okay, we're back. Sorry for the technical difficulties. Yeah, we'll just jump right into it. So it is, yes, thank you. No, don't apologize. You're clutching up right now for the Zoom people. You're the Zoom representative. Like, okay, great. Okay, yeah. It is with a heavy heart that I give my last official lecture of the course. I might give like a bonus lecture later on. But yeah, even though this is the last official lecture, this is a very important lecture. This is some like this lecture is basically like the foundation of all like industry level Android apps, which is this design pattern called model view view model. So yeah, let's just get right into it. First, some announcements. Please submit P5. We are still missing some submissions. The late deadline is tomorrow at midnight. You will get a 0 if you do not submit it by the late deadline. And if you like completely miss 2 assignments, you are at high risk of failing the class. And we don't want to have to deal with that. You don't want to have to deal with that. So please submit it. If you've already submitted it, great job. I'm proud of you. P6 is now released as well. This is going to be like a more challenging assignment because I wanted to like sort of model something that you might get asked like in an interview for like an online assessment or like some sort of like Android interview. So it's a bit more challenging. I recommend you get started early. And one important note about P6 is there is starter code, and the starter code is very essential to completing the assignment. So make sure that you use the starter code. Yeah, and then Hack Challenge is kicking off. Team Mixer is tomorrow at 5 to 6 p.m. in Gates G01. So yeah, cool. Okay, model view view model. So why are we bothering with learning this whole design pattern, right? We already know how to send network requests. We know how to store things locally in the app. We know how to create basically any UI at this point. So why are we learning something new? You know, what's the problem with this, right? Like, let's say this is the example from the networking lecture where we have a button and we just like send a network request in the on-click method of that button, right? And I would argue like this, there's actually nothing wrong with this. Like you can do this. You can have an app where you just like send the network request and on click and then like display the result manually. That's fine. But the thing is, like industry level apps tend to get more complicated. So let's take Eatery as an example. And keep in mind, like Eatery isn't even an industry level app. This is just like our project team, right? And here are some, this is like a lot of logic that I had to write for like basically figuring out like given it like a user has menu items that they favorite. So for example, maybe I really like chicken tikka masala, you know, I favorite that on Eatery. And then like basically I wrote this code to like find the eateries that like have that menu item on a given day. And you can see this is really long, right? This is pretty complicated. And imagine if I had all of this code inside of like an on-click button, right? The thing is, the UI becomes basically unreadable if we put all of our code into it. Like if we have all of our code in this like on-click lambda, you know, if we're trying to scroll our UI and figure out like where is this button like in our layout, it becomes basically unreadable. And we need like a standardized way to organize our code and like figure out our logic. So that's the motivation for a model view view model. Yeah, we want a standard way of compartmentalizing our code into 3 parts. And we also want to create abstraction barriers. This is like a really fundamental software engineering idea where basically by separating our concerns into 3 different, like completely separate parts, it makes it so we only have to reason about one part at a time. And it makes it a lot simpler to develop complex apps. Cool. So this is a diagram that I like a lot, and it kind of shows like how these really are separate components. And basically like the way that it works is the view receives data from, or yeah, we'll actually start at the model. So the model is like your single source of truth for data throughout the application. So like an example of this would be like in Eatery, we have this thing called like an Eatery repository. And that basically stores like all the information about our eateries, and that can be like updated by the view model. And then the view model also reads information from the single source of truth, right? And then the view model is going to like aggregate this data and send it down to the view. And the view might send UI events up to the view model. And then those UI events might trigger updates to the model. So like the core idea in this image, like I guess like two main takeaways here. The first is that like each of these are very separate components, you know? They should be able to like operate independently. And like that's the whole idea of like modularity in computer science is like you want to have this like separation of concerns. Then the other thing that I want you to take away from this is like the idea that data flows okay, actually it might be like okay, I'm pretty sure it's data flows down, events flow up. It might be like the directions might be reversed technically or something, but the important like the main idea is that like data is going to like start at your model and go to the view model. And then your view model is going to do like some processing like we saw over here with this like eatery code, right? Like at first we just have some like eateries and some favorite items. And then we have to like process that data and basically get it into a state that the view can understand. And then the data goes down to the view, and then the view will like display the data, right? But events actually flow upwards. Yeah. So the view will send an event to the view model, and then the view model, based on that event, might like update the model, right? And I think this also becomes a lot easier to understand through example. But like this is like your high level overview. Yeah. So again, the view is the presentation layer of model view view model. And it should only contain your UI components. All of the data that you get should just be from your view model. And it reacts to the view state. So yeah, one common mistake I see a lot when I'm looking at like model view view model code is like the view would contain what I like to call business logic. So I think yeah, we have this like that's like the view model's responsibility. But basically, like your view should be as simple to read as possible, right? So if we look at this example, like this is just like a random app that could exist somewhere out there, like a food displaying app. So we have this like food categories contract or sorry, food categories screen. And this screen, all it takes in is a state. And this state basically just specifies like what data this screen is going to display. So it takes in the state. And then you can see the UI is very simple. Like there's no actual like processing of the state, right? We're not like doing any special operations on it. We're just reading from it and we're directly displaying it in composable functions. So this is what you want your view to look like. Your view model will essentially retrieve all the data from the model and it will aggregate data in a view state. So that's that format I was saying. It's like really easily digestible for the view. So the view doesn't have to do like any special operations or special logic to be able to do it. Um, yeah, it also like defines how mutations are handled. So if we want to change the data, we would define that in the view model. And as I mentioned, like all the business logic, which is just um like logic that is like not related to your UI, should be in the view model. And here's a view model example. So what you'll see here is that um, basically, the view model exposes a state to the view. So here you can see this variable is public. That's pretty important. It's public and it exposes the state. And the state just is like a data class that contains all of the information that that view needs to display like whatever it needs to display. And you should do this in one data class because this makes it a lot easier to reason about where your data is coming from in your view model. So if your view model only exposes a single field, then it's really clear, like, okay, all of my data that I'm displaying in my UI is coming from this state. And it just makes your code a lot more readable. You can also see this like private set here. What this does is it makes it so our view can't change our view model. So that's like enforcing these abstraction barriers where basically like we want our state to be completely managed by our view model, and then our view just reads the state and displays the state. It should never have to edit the state, or at least like not directly. Yeah, and then maybe the view model, another responsibility is it loads data from the model. So here there's like a function called get food categories, and this uses this like remote source to get the data and then updates the state based on that data. And when we initialize the view model, we're going to like call this function. So this is one example of a view model. Yeah, and then the model defines how data is retrieved. And data could be retrieved in any way. We could have a remote source, we could have a cache, we could have like a repository, which is kind of like a combination of those two, and more, right? And the idea behind like why you might want a model is because like the view model just needs all it needs to do is like get data. It doesn't really need to know like how that data is actually being retrieved, right? Whether it's retrieved from local storage or like from the network. And this makes it like really easy. Like let's say my server costs were getting too high and I wanted to start moving some of my app on like the local storage of the person's device. Then all I would have to do is change the model and everything else in your app should still work the same. Yeah, it acts as a single source of truth. So models are typically singletons. Like there's one instance of a model throughout an entire application. And yeah, they're just like retrieve data from whatever data source you have. And here's another example. So this is a model implementation as a cache. So in this case, we have like a private variable that stores like the cached items. And then now whenever we want to get the food categories, we check like if it's in the cache, right? And if it is in the cache, then we can just like return it. But if the cache is null, then we can like update the cache and then still return those like cache categories. Um, yeah. And then this is like more just kind of like similar logic that you might see. But yeah, so then the main idea here is that like this repository, like it could really be doing anything to get this data. And it shouldn't matter to the view what it's doing. It's like it's an abstraction barrier where it just says, like, I have all these methods that allow me to get data that you can use in your app. So yeah. Yeah, and there's that like diagram again, except I kind of put in like a bit more. There's like, or I didn't I actually stole this from the internet. But I made it like a little bit more overwhelming, I guess, with more arrows, right? So this is kind of like the um we have like model change events that could be flowing down as well. So let's say you have an app that displays live data. Like your model might send an event to say like, okay, that data has changed. We need to like give something to the view model, and then the view model would send an event to the view, right? But yeah, again, the key idea is that like these are each abstractions of like very separate tasks. Cool. Okay. Any questions on that before we move on to flows? Okay, cool. Yeah, so let's talk about flows. Before I talk about like what these are and why they're useful, I want to again provide motivation. Like, what problem are we trying to solve? So let's say we have a source of data that provides a list of eatery IDs that the user has favorited. And then we have another source of data that provides a list of eateries that are in the app. And the idea is like we want to display the favorite eateries to the user, but we only have their IDs. So a solution you might propose is like, okay, we could map the favorite IDs to eateries from our list. But there is still a problem with this. So what if the user favorites a new eatery? We would have to remember to manually update the value that like this mapping function. So let me show you in code like what this actually looks like. This is an example of what our view model look like. So we're doing that. We're exposing the state just like you saw in the other example. And then the thing is, we only have access to two methods in the repository. We have access to get favorites and we have access to get eateries, and they return a list of eatery IDs and a list of eateries respectively. Um, and then and then like we basically can use these responses to update like the favorite eateries, which would be the filter. Like we apply the filter to see like if the eatery ID is in the list of favorite eatery IDs, right? And that's all fine. But then now what happens when we write this add favorite function? So we call the repository to add a favorite eatery ID, but then our UI wouldn't update, right? Because there's nothing updating this variable. So what we have to do is run calculate favorites again. And then we would have to relaunch these two calls to our repository to get the updated information. And then we would have to like rerun this calculation, right? And you can see like how as a developer, it would be very easy to forget to call calculate favorites when you're implementing this method. We don't want to have to recall calculate favorites like manually every single time. Ideally, we want a data structure that can do that for us. right? So yeah, does everyone understand like why this kind of isn't like the optimal thing to do here? Like ideally we don't want to have to call calculate favorites again. Um, and we don't want to have to like keep, querying all of the data from the repository every single time one thing updates. So, yeah, any questions on that? Okay. So this is where we introduce flows. So this is like some AI generated images from Dolly 3. Here's like your packet of data flowing down the river. And here you are waiting for this data to come. And then you observe the data with a function called on each, or you might end up using combine, which we'll go over more in depth today. Um, and you pick up this packet of data. And yeah, think of a flow like a river. So basically, data can flow down this river at any time, and we're constantly observing the river and processing new data that flows down it, right? So let's say we have like a live counter app. I don't know if anyone remembers like T-Series versus PewDiePie, the subscriber counts, right? If you wanted to make that into an Android app, you'd probably want to use a flow of type integer. So the way that it would work is basically this flow would emit a new integer value whenever the subcount changes. And that integer value would be the value of the entire subcount. It wouldn't be a change like, oh, they gained one subscriber or lost one subscriber. It would be like the entire subcount. And that is what like we'd want to do. So flows again, like down this river, right? These are like entire packages of data. They're not just going to be like little changes or anything like that. And the like data from the flow should always contain the latest value. Um, okay, so like here's like a more programmatic example of this. You're not really going to be using flows like this very much in Android actually, but it kind of just shows like what a flow actually is. So we have this flow of type int, and we use this like constructor basically that specifies a flow collector. So the flow collector is just like a method that allows us to emit values to the flow. So let's just say like we're showing like the latest stock prices or something, right? So there we call this like every second we like call this API, and then we would like emit the latest stock price. And then if we wanted to like watch this flow, we would call dot collect. And dot collect would like block it basically like block this thread as in like it wouldn't go to this next line. It would keep collecting it until the flow stops emitting values, and it would print like what the stock price is. So yeah, that's a little like programmatic example, but you're not really going to be interfacing with flows like this that often. It's more just like showing, kind of like an idea of how it works. So yeah, I guess like the main important thing is like this dot collect. You're gonna pass in a function, and that just says like whenever I receive a new value from this flow, here's what I want to do. And in this case, it's like printing something. Okay, so why is this important? Remember, compose is reactive, right? So we shouldn't like the flows kind of inherently have this idea that we're observing changes and then making an action like based off of them, you know? And it's kind of imperative in that way. Like we're explicitly telling the code to do something whenever a value updates, right? Like, shouldn't this be a part of more like, shouldn't we be doing things more reactively where we have a state and then our UI just like reacts to that state? Well, yeah, we actually can. So we can incorporate states into flows using a state flow of T. So the view models, like when you work in industry, they're not actually going to expose that mutable state that I showed you earlier. They're going to expose a state flow to the client. And then the client can use collect as state to basically, instead of like, so before in our example, we had to use dot collect and then manually run code every time the flow updated. But we can actually, like in Jetpack Compose, you're able to use a collect as state function, which basically just allows you to like use the latest value that's emitted from the flow as a state variable, which means like the UI will automatically get recomposed. So this is super helpful. And then the other really interesting thing that makes flows super valuable is combine. And this allows you to combine different data sources into one state, right? And this solves the problem that we presented at the beginning. So here, this was our problem at the beginning where we basically had like we got favorites, got eateries, and then every time we wanted to add a favorite, we had to recall calculate favorites. And like at a high level, what the solution to this problem would look like is we would say, okay, instead of like using a state, just like a mutable state, we're going to use a flow. And these get favorites and get eateries would be implemented as flows as well. And what we'd be able to do is combine these flows and then use the collect method to say when either of these flows emits a new value, then we update that view state. So that's pretty high level, and I want to go into a demo of like how we can actually use combine and set up a view model. So yeah, we're gonna get into that. First, does anyone have any questions on anything at all in the lecture? Okay, cool. We have a lot of time. That's great. Okay. So let me pull up Android Studio. Oh, I can't have. Hmm, that's fine. Okay, I'll just put it. Um, okay. Yeah. So, oh wait. Okay, I don't want to have to keep looking back, so I'm gonna try to see if I can fix that. Yeah. Um. Oh, like. Yeah. Wait, I feel like it might be too laggy though. Let me see if this will work. Yeah, because I'm like changing the config. So, okay. I guess it's a bit smaller, but I feel like I hope everyone can see it okay. This is the wrong project. Um, yeah, I think everyone should be able to see that okay, and then I can see it okay, which is good. Um, yeah. Okay, Zoom time. Cool. Okay. So actually, I think this is a good opportunity as well, since we have some extra time. For P6, this is what the starter code is going to look like. So just to give you like a head start on P6, I want to introduce the starter code, and then we're going to work with the starter code to implement model view model. Okay, so I tried to organize it kind of like what you'll see in industry. So we can just start at the top. We have this data folder, and this contains two subfolders, the model and the remote. And the model is like what we talked about for a model view model. We have this repository, and the repository depends on this API. You're going to see like notation in this code base that you're a bit unfamiliar with, such as like at inject, and like at singleton, you might not be very familiar with, or like over here, right? There's like a lot of boilerplate, like app provides at singleton. There's like these weird functions. So basically, when you implement like model view model in an industry setting, you use a pattern called dependency injection. I'm probably going to give my bonus lecture on this if you want to learn more about it, but I'm not going to be going into it today. So for now, just like ignore the at inject, and basically we can just like magically get a singleton instance of our API to work with. So we can see like my repository gets my API, and like right now the repository isn't implemented, so it just like logs, okay, I have the API to work with. Um, and then there's the remote. So this is just like the API specification that you guys saw in P5, where you have an interface and you want to annotate it, right? And then this DI, so that stands for dependency injection, which is like the pattern that we're not gonna really go over today. But basically what this is doing is like providing singleton instances of different like app components. So like this is providing the API, and then this is like a bit more boilerplate. You can kind of ignore this file when you're implementing P6. Yeah. And then have like a main screen. And again, like I did the dependency injection for you, so you can access the view model through this parameter. And then here's the view model. So you can see the view model has like this main screen view state data class, and that's empty. And I gave you a to-do that you want to like specify the screen view state. And then here's our main screen view model, where we're gonna like specify any business logic that we might need. Okay, so our task for today is we want to create a sign-in page for our new app. So what we're going to need to do is create a username field, a password field, and a confirm password field. And the thing is, we want the confirm password and the password to match. And we want the password to be at least 8 characters long. And if if any of those conditions fail, we want to show an error state to the user. So like the way that you're used to doing it would probably have this, like you might put that logic in the UI. But we're going to use flows to like combine all of these input fields and neatly display an error message to the user. Okay, so if we have our main screen view state, I think it's easiest to fill this out first because the main screen view state, you can kind of think of it as a contract of like, hey, I'm specifying like this is the data that I'm going to provide to my UI, you know? So if we need like if we need the UI to be like or the main view model to be responsible for like showing these error messages, right? Could anyone like name even just like a single field that we might want to put in this view state? Just one field. You got this. Um, One way to think about it is like, what information does our UI need? So like just as a refresher on the problem statement, we want to implement a sign-in page that takes a username, password, and confirm password, and then like potentially displays an error message. So, does anyone know like what properties might we want to put in this main screen view state? Yeah, yeah. That's a very good start. So, we can say our username is a string, and yeah, we can just set that to the empty string for now, and I can delete this. Okay, password. Right? And then the other thing I mentioned was like the confirm password, um, which is also going to be an empty string. And yeah, so that's like the main information that we want to display. But then the other thing that we need to display in our view is that error message. So let's just say we're also going to expose an error message, and that's going to be a nullable string. So null indicates that there's no error with what the user is typing in. Okay, cool. So that's our view state specified. And now the main idea is like we want to basically define a flow for um, each of the username, password, and confirm password, because those are going to be updating at any time. Like the user can type in something and then we could get a new value for it. And we want to like react to that new value immediately. So we're going to use flows for these. So we're going to declare a username flow. Um, and that's just going to be the empty string, a password flow. And these should also be private because we don't want our view to be able to like modify these directly because we want to keep this logic inside the view model. So username flow, password flow, and then we want our confirm password flow. Um, okay. And we actually don't need a flow for the error message because we're gonna be like that's a value that we control. It's not like we're just gonna randomly get a new value flowing down the river for the error message. We're gonna basically derive the error message by looking at these flows. Okay. So those are our 3 flows. And then now we want to expose the view state. So here's how we're gonna do that. We're gonna give a public variable called view state. And we're going to say that that's the combination of our username flow, password flow, and confirm password flow. And then we need to like capture these parameters. So I'll just type this out and then go over it. And then, all right. Okay. I think it's easiest to just type it out first. So, all right. And then we need default value. Okay. So, okay. So yeah. What I was saying before was like we wanted to basically expose a state flow. So if you guys remember that from that slide on state flows, right? We want our flow to be observable to the UI as a state. So the UI can just react to it. So personally, I like having these type annotations here because it just helps me remember like what the contract of like the what is like the view model providing to the view, right? So this is like kind of the contract. It's saying I'm going to provide you with a state flow that contains my main screen view state. Okay. And then what we have here is we have this combine statement. So what combine does is it will run this like lambda function here, right? And it will run it whenever any of these flows change. So that's what's really powerful about this is like if I had a method to update the username, right? I don't actually have to like call any like calculate error message code, you know? Because whenever the username flow updates, whenever any of these flows update, combine will automatically call whatever is in this lambda. And then these are basically the three values that we're capturing in this lambda. So username contains the latest, like whenever this lambda is called, username will contain the latest value from the username flow. Password will contain the latest value from the password flow, right? And then confirm password is going to contain the latest value from the confirm password flow. And then right now, right, this combine function, it's going to return. You can see it takes flows and then it returns a flow, right? So what actually happens here is we're basically taking these three flows and we're taking their variables here. And then we're combining this into a main screen view state. And then this combine is going to like return a flow of type main screen view state, right? Since combine takes flows and it returns a new flow. Since it's like always emitting a new value whenever any of these flows change. And then what we do is we want this to be a state flow. So we use the dot state in function. Okay. And yeah, view model scope is like that's just the coroutine scope that we use in view models. And if you want to like for a more in-depth explanation, I'll probably go over that for dependency injection. No one knows what this means. And then main screen view state. Yeah, that's like the default value for the flow. So I just said, okay, the default value is like um just yeah, the main screen view state, not passing in anything, right? Like we just call the constructor on the data class. Um, okay, but the thing is like we actually have to, use this data to calculate what the error message is going to be. So yeah, I want to pause here for questions if there are any. Okay. So now we want to calculate the errors. So we can do something kind of nice here, which is we can declare like um a base view state is what I'm going to call it. And we're going to say that that's equal to our main screen view state. And it's just going to say, and we're going to pass in username, password, and confirm password. So what this does is we're just saying, okay, we're going to create a view state that contains all the latest information for username, password, and confirm password. And like the reason that we do this is we want our UI to always display like the latest information about what the user has typed in. The only thing we're modifying is the error message. And because we're only modifying the error message, we can like abstract out this portion that we're not modifying. So that's our base view state. And then let's like check for some things. So if the password length is less than 8 characters, and then we can give the combined statement back a view state that has an error message. Um, and this error message is going to say password too short. Yeah, and this like dot copy function basically just takes this view state we already made and copies it, but then changes one of the parameters. In this case, the parameter is the error message. And then we want to add some other checks. So like if password is not equal to confirm password, then we can also give an error. And this time our error message is going to be confirm password does not match. Okay. And then the last thing that we're gonna do, oh right. Let's say like, okay, we don't want the username to be equal to the password. That's like too insecure. So then in that case, we're gonna say our error message this time will be oops, error error message. And that's just gonna be like, okay, username cannot equal password. Cool. And then what we're gonna do, and then if we've like made it past all of these checks, then we can return the view state with no errors. So we're gonna return just like the base view state. Because if you remember, the default value for the error message is null. So when we create this base view state, it has like no errors, which is good. Cool. So now hopefully you're able to like understand that this view state will always contain the latest information that the view needs to display. And that includes like the username, password, confirm password, and any potential error messages. So that looks pretty good. And we're gonna go into our view now. So we can close out of these. And here's our view. We have access to our view model. So I'm just gonna start by just for looks sake, we'll add a column that is gonna fill max size and just like center everything. Oops. And then yeah, center. Okay, nice. And then here we can like create some labels. So our username, and then we can use a text field and the value. Uh, okay. So now we want to like get our value and we want to like we want to observe the view state as a state, right? Right now it's a state flow, but we want to observe it as a state. So we're going to say val view state equals view model dot view state dot collect as state, right? And collect as state, this returns a state of main screen view state. So because this is still like wrapped in a state, we need to call dot value. And then this will give us the actual main screen view state value. And we want to, again, like store all of this like logic in our view model. So the value is going to just be the username that is emitted from the latest view state. And then we still need to say what happens when when the value changes. So what happens when the user presses a key and we get a new value for this text field. And for that, we're gonna have to set up wait, is this still 9:35 or 9:25? Yeah. Okay. Yeah. Okay. All right. I'm just trying to time myself. Okay. Yeah, that should be fine. Um, okay. So we're going to have to like have a way to basically send this new username value to our view model. So you might be tempted to just make this public, but like that is not, I will say that is not good practice. Like it would work, but it is not best practice. And the reason is like you want to make sure you have this abstraction barrier. So if I made this public, then what I would have to do is I'd have to say like view model dot username flow dot update, right? And you can see how when I do this, when I like write this code, the view is now like partially responsible for this logic. The view knows that the username is stored in a flow. But what if I want to change that later? If I want to change that later, then I'm gonna have to change a bunch of logic in the UI because now the username is not stored in a flow, right? So we need this abstraction barrier. And to create such an abstraction barrier, we're going to make a function. So we're going to make a function called onChange username. and this is going to take a username. And then we're going to update our username flow. So calling dot update is basically equivalent to doing this. So you can say dot val username flow dot value is equal to username, and that updates the value of the flow, and it causes like all of the flow collectors to rerun their code, right? Automatically. Like we don't have to do anything for this, which is really nice. And personally, I prefer the look of dot update, so I'm going to use that. So dot update username. And now you can see like we've created this abstraction barrier. So if we go back to our main screen here, right? We can say that on value change is equal to view model on change username. And this colon colon, right? Remember like higher order functions, we can pass down functions as values. So this colon colon like basically gets the function from the view model as a value and passes it into on value change. And just to be clear, this would be equivalent to writing it out like this. If you had view model dot on change username, and then here we'd have like a username, right? So it's equivalent to writing out like this, where you're explicitly calling the function. But like we have higher order functions, so I'm going to use them and just pass this function by reference. Okay. So there we go. View model on change username. And now the nice thing about this is like the UI doesn't have to know anything about what actually happens behind the scenes when we change the username. We can update this however we want. We can use whatever data structures we use in our Apple we want to use in our Apple not break, which is great. Um, cool. So yeah, you can see like a lot of industry thinking is about like future proofing. That's something that I like thought was really interesting. How you're always trying to think ahead, think like how could I possibly change this API and like how can I make it more robust, right? So okay. Now we're gonna change all of these very similarly. So yeah, this is like very much the same as we went over before. So I'm not really gonna comment much on it, but yeah, so confirm password change. And then we just want to update the confirm password flow. So yeah, there is a bit of boilerplate for this abstraction barrier, but it is definitely worth it. Oh wait, yeah, okay. Unchange password, and then sorry, just to make these the same the same way. Okay, cool. We have 2 minutes. This should actually be fine. So then we have our password, right? And then here we want this to be the password and on change password, and then confirm password, and then this again, right? So really just the same thing as username. And then now we want to show our error message. And the cool thing is like why I think I can get this done in 1 minute. Well, we'll see. Is that we already did like all of our logic, right? So this has made it really easy for us. All we have to do is read this error message, and if it's not null, then we can show it. And then we can just say that this is like red. Red. Yay. Cool. And you can see how clean this is. Like we're just calling text composables, right? There's nothing like fancy going on here. And here it's like very clear too what's going on. So let's just run this app and hope that it works. And maybe I can get it done. Let's see. Hey, oh. Oh no. Okay, I'm 5 seconds over. And yeah, as this loads, like, yeah, I actually don't know. We went over everything. Okay, cool. Yeah, you can see like the password is too short right now, so let's make it longer. And oh, our confirmed password does not match. So it automatically updated. Very cool. And then we can like try typing the same thing. And now it matches. But if our username matches, then we see an error. Oh, username cannot be equal to password. But if I add like another character to this, it goes away. And yeah, you can see like even though there is like the logic can be like kind of complex, right? Where we've made it very simple. Everything is just like in our view model, we're combining these. It's like very clear what's going on. And same thing with our UI. So that is how you organize your code, model view model. And yeah, next demo we'll go like more in depth, but yeah, you're free to leave or ask questions if you have any.
I like the background. The AI.
Oh, yes.
Or are they supposed to be flows? Just